to this video tutorial for Paramics Discovery 25. We're bringing another new feature to you today, which we included in version 25 when we launched it last November 2021. And today's feature is all about speed distribution and how you can now customize that within Paramics Discovery. So let's dive straight in and have a look at how this new feature works. So I've got a model in front of me that we're going to be using today to look at how we can now vary the speed distribution within Paramics Discovery. I'm in the Visualize tab within this model, and the first thing I'm going to do is have a look at the different types of links I've got in this model, and therefore I'm going to be able to see the speed limits of the network. So if I open up my Styles panel, so Visualize and Styles, and I'm going to open up my links here and choose to view the links by category. So when I toggle that on, I can now see a list of all the link categories that are used within this model, and I can also see a color coding for each link category. So I'm quickly able to see the speed limits of the different links within the model. Now I'm going to zoom in this area here where I can see I've got this urban 30 mile per hour major link, and I'll just zoom down in 3D mode to see that link a little bit more closely. And I'm going to get my simulation going, and I'll speed that up just to get some traffic onto this network. Okay, so I can see the link categories and the speed limits. That's going to be important for this demonstration. The next thing then is to actually be able to mark vehicles so I can see the speeds that they're doing on the links. Now we've got a previous video in this series all about vehicle marking, so you can go back and look at that in more detail. But the marking option is again in this traffic section within my styles panel, and I can turn that on, and I want to choose in the drop down beside marking speed. Okay, now what this is showing me is that the vehicles will be colored different colors depending on what speed they're doing at any given time on the network. So if I zoom in more closely on this link, I can see the cars are colored in blue. That's showing me that they're doing between 30 and 40 miles per hour. Okay, now if I select an individual vehicle, I can see the speed that it's doing in more detail. I can see the exact speed it's doing here. We've got 31 miles per hour for this car. This one is 32. And the next one along is also 32. Okay, and I'll just get the simulation running and let the traffic flow through. So the vehicles on this section of the network where the speed limit is 30 miles per hour, they're all doing just over that 30 miles per hour limit at the moment, and that's why they're all colored in blue. And again, if I pause another couple, I can see 31, 31 in those cases. Okay, I'm going to switch across to the Edit Network tab, which is where we can set the speed distribution for the vehicles on the network. And this is done at the category level. So if I go to Edit Network in the top menu and Categories, I can see all the link categories within the model here. The link categories are listed on the left-hand side, and the details of each link category are on the right-hand side of this dialog. Now the new part in version 25 is this speed distribution at the bottom. So I'll just choose the first link category, which is urban 30 miles per hour and major, and toggle custom. And that now gives me the opportunity to edit the mean speed and the fixed spread of the speed distribution. I'm going to explain what both of those are in a moment. Now these are actually the values on urban links that are used as default, the mean speed being 110% of the speed limit and the fixed spread being 10% around that mean speed. So what that means is if we've got a speed limit of 30 miles per hour, the mean target speed for vehicles will be 33, so it's 10% over the 30 miles per hour. And the fixed spread is then 10% around that 33, which will range from 30 miles per hour to 36 miles per hour. So on an urban link, by default, we'll get a range of 30 to 36 miles per hour. If I just go back quickly and look in my Visualize tab, I'll select a few more vehicles and just confirm that they all sit within that range. So that was 32, 34, there's another 32 and a 35. So all of the cars are sitting within the range of 30 to 36 miles per hour. Now, in lots of cases, that might seem a little bit high. We do know that vehicles do break the speed limits on urban links often, and some of the slower speed limits, like 20s and 30s, can be broken very easily. On the other hand, in many models, that can be too high. Now, the way that we would have done this in the past or dealt with this was to reduce the overall speed limit on the link, and that would reduce the mean speed at this 110, and also it would reduce the overall spread because it's bringing down the mean speed. But now we don't have to change the speed limit in order to achieve that. We can change the mean target speed and the fixed spread instead. Okay, so I'll make quite a dramatic change here just to illustrate the point. Let me bring the mean speed down to 67% on this link, and 67% of 30 miles per hour will be 20 miles per hour, so they're going to be aiming for 20 miles per hour. And we'll make the fixed spread around that 20 miles per hour quite large, so we'll make it 25. And 25% of 20 is 5 miles per hour, so they should range between 50 miles per hour and 25 miles per hour on this link. Okay, so I'm going to close that. We'll save the model, go back to visualize and refresh and start the simulation. We'll speed it up to get the traffic on. Now immediately you can see, and I'll just slow it down a little bit, that the vehicles on these links are the orange color, which shows that they're sitting somewhere in this, well, 10 miles per hour to 30. So some of them will be the darker orange, some the lighter orange color. So that's looking pretty good. That looks like we're probably in about the right range. It just shows that the new vehicle marking can be very useful, showing you the speeds of vehicles on the links really quickly. Okay, so let's just pause the simulation and select a vehicle. Here we've got a van doing 19, a car doing 19. We've got another car also doing 19. And here we've got some cars in the other direction. There's one doing 23. 21. 21. And another 19. Okay, so it's all sitting in that range of 15 to 25 miles per hour, and you will get most vehicles sitting in the middle because it's a normal distribution of traffic. And so most of them are going to sit around that 20 mile per hour mark with the spread going from 15 to 25. So in this example so far, we've looked at reducing the speed distribution on a link with 30 mile per hour speed limit so that the mean is 20 and the spread around that is 5 miles per hour. And we've seen the effect of that. Now, this correlates with how speed distribution occurs on urban links, whether we customize it or not. On urban links, the speed distribution always has a mean value and a fixed spread value, and the defaults for urban links are the 110 for the mean and 10% for the fixed spread. So any previous model in Paramics Discovery would have had that. Now on highway links it's slightly different. There's a few more variables involved in how the speed distribution works on highway links, and it really depends on which lanes vehicles are in. And so essentially you get a higher mean and a higher spread the further out you go in the lanes. But what we've done in this version as we've introduced the ability to customize speed distribution is actually make the highway links as simple as the urban links. So by default, you will have a variation in the speed distribution by lane on highway links. But if you customize it, you will use effectively the same method that you would then use on urban links, having a mean value and then a fixed spread that applies to the whole highway link irrespective of what lane you're in. We've done some tests on this and this works really well actually, because although we're using the same mean and fixed spread for all the lanes on a highway link, you do actually get a spread into the outside lanes of higher speeds and higher spread as well. And that's because of the passing behavior on highway links. You get the more aggressive vehicles in the outside lanes, the less aggressive on the inside, and so you do get those higher speeds and higher spreads in the outside lanes anyway. But if you customize it, you still use exactly the same values that you would do as working in the urban link environment. So if we have a quick look at a highway link in this model, we'll just check some of the speeds of the vehicles just to see what those are and if the distribution looks about right. So I'll just go back to my Edit Network tab, Categories, and you can see here I've set that customized speed distribution. The mean is 110%, so that will be 77 miles per hour with a fixed spread of 10. So it's sort of plus or minus 7 or 8 miles per hour. So we're looking for something between 70 and 84, and we're expecting our faster vehicles to be in the outside lanes or the ones that are passing in general. Okay, so if I select some vehicles, we can see here outside lane we've got 81 miles per hour. On the inside we've got 71. There's a vehicle passing here at 83. One on the inside again doing 71. 73 on the inside. 79 on the outside. 80 on the outside, and in this case 80 on the inside as well. So you do occasionally get a faster vehicle on the inside. So that gives you a sense of what the spread is there, but you also do get that spread between the lane 1 and lane 2 or inside and outside lanes, because it is those more aggressive vehicles that pass, those are the ones that tends to do the higher speeds. Thank you so much for joining us today for this video tutorial, which has looked at how you can now customize the speed distribution within your Paramics Discovery model. We think this is going to be really useful to just help you calibrate and improve that vehicle behavior even more within your models. So thanks again for joining us. We're going to have another video tutorial in the next week or two, and we look forward to seeing you then.